Assalamualaikum warahmatullahi wabarakatuh. We are from Group 3 and from the class of EH1104C, and right now we will do a presentation about the distillation column Aspen simulation. Our group consists of 4 members, which is me, Nurul Khairi Hazauni binti Kamaruddin, Siti Sarah binti Muhammad Saleh, Nur Zaidatul Adila binti Zaina, and next is Nur Afifah binti Muda. So this is the problem statement for our Aspen simulation. A feed mixture consists of 40% ethanol solution is fed to a distillation column at a temperature of 85 degrees C and pressure at 3 bar. The flow rate of the feed stream is 100 kmol per hour. The flow rate of the distillate is 30 kmol per hour and the reflux ratio is 2. The column consists of 30 bubble cap trays. The feed tray is located on the number 10 tray. The pressure on tray number 1 is found to be 1.01 bar. The mole fraction of ethanol at the distillate should contain at least 0.83 and at the bottom stream not more than 0.22. Based on this condition, simulate the process for this distillation column. You may improve the mole fraction at the distillate and bottom stream by increasing the reflux ratio to 4. The following is the information for the distillation process. First, we have to create a blank simulation. Next, we have to set the global unit to metric bar. The third one, we have to insert the component which is ethanol and water. The fourth one, we have to set the method filter to common. And the fifth one, we have to select the thermodynamic property method to NTRL based method. The specification of the distillation column can be shown from table 1 and table 2 here. Name of the column is DC red flag 1. Name of the stream is feed. DIST distillate and BOT for bottom. The type of the column we'll be using is equilibrium column. And the second table explained to us that the number of stages is 30. The type of condenser is total condenser and the type of reboiler that we are using that is kettle. In order to create the flow sheet, first we have to choose the column which is DC red flag 1. Next one is we have to click the material to connect the distillation column, and the third one is we have to rename all the equipment and the streams according to the name that have been stated in the table in the previous slide. So the figure that we can see here is our final process flow diagram for our Aspen simulation by using the guideline that have been stated in our task.
So I will proceed about the information of the feed. The first thing is we need to double click on the feed stream and then fill in the state variable at temperature 85 degrees Celsius and the pressure of 3 bar. Next, we change the composition to mole flow to get the unit of kilomole per hour, and then we insert the value of ethanol which is 0.4 and the water which is 0.6. Next, we also need to fill in the information of the distillation column. The first is double click on the distillation column equipment and then set the calculation type to equilibrium at the configuration part, and then set the number of stage to 30, the condenser to total, and the type of reboiler to kettle. Next, we set the distillate rate to 30 kmol per hour and the reflux ratio to 2 mol. Next, we fill in the feed stage to 10 on stage in the stream distillation column part. So I think that's all from me. I will pass to the next presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Afifah and now I will continue with the information of the distillation column. For the next part, you need to click on the pressure option and then convert the view to top or bottom. Next, set the stage 1 condenser pressure at 1.01 bar. And after finish with all the information, you may run the streams. As you can see, this is the result stream of reflux ratio 2. For the result stream of reflux ratio 2, the molar flow rate at distilled stream is 30 kmol per hour and bottom streams is 17 kmol per hour. The mole fraction of ethanol at distilled stream is 0.80959 kmol per hour and bottom stream is 0.224462 kmol per hour. And this is the graph that we can observe for reflux ratio 2 after we run the simulations. And now I will pass to the next presenter.
Assalamualaikum warahmatullahi wabarakatuh. So, I will continue with the information of distillation column for the different reflux ratio. For the reflux ratio of 4, we have to go back to the configuration part. Then, we have to change the reflux ratio from 2 mol to 4 mol at the operating specification. After we run the simulations, we will get all the results. For the result stream of reflux ratio 4, we can obtain that the molar flow rate at distilled stream is 30 kmol per hour and the bottom stream is 70 kmol per hour. Next, the mole fraction of ethanol at distilled stream is 0.834441 kmol per hour and the bottom stream is 0.213811 kmol per hour. Lastly, this is the graph composition plot of reflux ratio 4 after we run the simulation. So, I think that's all for our presentation for the Aspen simulation of distillation column. Thank you.